Okay, you've now studied alternating series and decided if they are convergent or divergent. What we're now going to be looking at is the absolute convergence test. So at the end of this lesson, you'll be able to determine whether an alternating series converges conditionally or absolutely. We have the absolute convergence test. We'll be deciding whether it converges absolutely or conditionally. So first of all, we need to know that it converges. And then we're going to say, does it converge conditionally or absolutely, right? The absolute convergence test just tells me that the series will converge absolutely if the absolute value of the series converges, because that would make it converge absolutely. All right, so we are just going to jump right into an example. It says to determine if the series converges absolutely, converges conditionally, or converges absolutely. All right, so what we are going to do, I'm going to tell you if we did our tests on this one just to save us a little bit of time, we would find using those three tests that this one converges, and we just need to figure out, does it converge absolutely or does it converge conditionally? So what we are going to do is find out whether the absolute value of this series. So we're going to find the n equals 1 to infinity of the absolute value of negative 1 to the n plus 1 over 0.1 to the n over n. Does that do? Well, I didn't want that there. Okay. And if we were to take the absolute value of that, then obviously that part is not there anymore. So we're really just looking at 0.1 to the n over n. We would like to find out if that converges or diverges, and we actually are going to use our tests from chapter 11a to help us out with that one. And since I see a power, I'm going to go ahead and use the root test to decide that. So if I'm doing the root test, we would like to find the limit as n approaches infinity of the nth root of 0.1 to the n over n. And I'm going to separate this into two parts, so I'm going to have 0.1 n to the nth root, and then n to the nth root. All right, so in the numerator, the n power and the nth root will cancel each other out, so just be left with 0.1. And down in the bottom, that's a limit that arises frequently. Hopefully we know that that limit is equal to 1. So if I figure that out, that's equal to 0.1. And using my root test rules, I know that this value is less than 1. And since that value is less than 1, I know that this converges. Okay, so since we found out that the absolute value converges, we can say that this series converges absolutely. And there we go. So this really just gives us, I like this section actually because it gives us good practice with our rules from last chapter. All right, let's try number 2. This first of all, if I were to do my checks, which again, I'm not going to go ahead and take the time to do because that was the previous video. If we did our 3 checks for an alternating series, we would find that this series converges, okay? But now we just need to find if it does so absolutely or conditionally. So we're going to go ahead and take the absolute value of this, and if I do that, again, what part's going to drop out is that negative, so I'm just going to be left with 1 over the square root of n. So now we just need to decide if this converges or diverges. And I'm going to rewrite that as 1 over n to the 1/2. I do notice then this is a p series, and again, great practice from last chapter. We got p series, p is going to equal 1/2, and since I found that p is less than 1, I know that this is actually going to diverge, right? But since we already found out that our main series converged, it just doesn't converge absolutely. It doesn't like double converge. So we will say that this series converges conditionally. There are conditions placed in conditionally. So there we go. So hopefully now you can tell if an alternating series converges, does it do so absolutely or conditionally?